Hello, student. Today we are going to learn Standard 12 probability. In conditional probability, till now in probability, we have discussed the methods of finding the probability of events if we have two events from the same sample space. Does the information about the occurrence of one of the events affect the probability of the other event? Let us try to answer this question by taking up a random experiment in which the outcomes are equally likely to occur. Okay, so consider the experiment of tossing three fair coins. If we toss three fair coins, then what could be the sample space? The sample space is H H H T H T H T H H. Then H T T T H T T T H and T T T. Right? Dear students, now the question is, since the coin are filled, we can assign the probability 1 by 8 to each sample point. Means each and every element individually we can say probability is 1 by 8. Let let us consider E with the event such that at least at least two heads appear. Then F be the event, first coin shows tail. First coin shows tail, right? So if as we are assuming E as event, so what are the sample space for E? What are the sample space for E? We have H H H H H E H T H T H H, right? Then similarly for F we have T H H T H T T T H T T T, right? Now the probability of E is we have four, right? We have four elements over eight. So total sample spaces. So we write number of elements in E divided by number of element in S. So we write what 4 over 8 is 1 over 2. Similarly, P of F equals to number of elements in F divided by number of elements in S. So what we have again in F also we have 4 over 8. So our answer is 1 over 2. Now, what we are going to do is that P of E intersection F. For that, let's try to understand E intersection F. So, what are the elements that are intersecting in E and F? Observe carefully. We have THH, THH, right? Then what we have? Is there any other elements that we are intersecting here? Only one, right? So, the probability for this one is here we have THH, only one element. So, the probability is 1 over 8. Here, the point. Now, suppose we are given that the first point shows tail, F occurs, then what is the probability of occurrence of E? With the information of occurrence of F, we are sure that the case in which first point does not result into a fail should not be considered while finding the probability of E. This information reduces our sample space from the set S to its subset F for the event E. In other words, additional information really amounts to telling us that the situation may be considered as being that of a new random experiment for which the sample space consists of all those outcomes only which are favorable to the occurrence of the event E. Okay, you might be getting confused. Here, the sample point of f which is favorable to event E is T H H, right? So the probability of event E is called the conditional event of E given that f has already occurred. Here, what actually I'm explaining is that in conditional probability, we say that, okay, so the the probability the probability of E of the event E is called the conditional probability of E, given that f has already occurred and is denoted by P of E of f. So, how we actually write is, dear students, observe this formula, how we are deriving it. Okay. So, P of E occurred from F is, we also can write the conditional probability of E given that is number of E intersection F divided by number of F. It means, can I write like this? E, E intersection F divided by number of S whole divided by number of F divided by number of S, and this complete is defined as P of P intersection F divided by P of F. So we can define conditional probability as, but here the condition is P of F is not equal to 0, or we can say F is not null set. Okay, dear students, here I'm writing definition of conditional probability if E and F are two events. What I'm writing, if E and F are two events associated with the same sample space of a random experiment, the conditional probability of the event E given that F has occurred, P of E f is given by. So how we write this? P of E over F is given as P of E intersection F, probability of F. Okay, dear students, this is the formula for conditional probability. And how we define E, even E given that F has occurred. Okay, so there are few properties that we are going to learn here. Properties of conditional probability of conditional probability. Probability here, if property one, if P of S of X is P of F equals to 1, then we know that P of S of F is P of S intersection F divided by P of F equals to P of F upon P of F equals to 1. Similarly, if P of F equals to P of F intersection F divided by P of F equals to P of F upon P of F equals to 1. So P of S of F equals to P of F is always 1. Now, similarly, for property 2, if A and B are any two events of a sample space S and F is an event of such that if is not equal to 0, then of A union B, conditional probability over F equal is given as